The last part of the question is the battery is formed from the cells of EMF 1.5 volt. Explain in terms of electrical energy what is meant by electromotive force. Avata, can you tell me what is meant by electromotive force? Sir, 1.5 joules work is done. 1.5 joules work is done to convert any form of energy, and it is a cell, so we can write chemical energy. It is given that it is a cell, so we write to convert chemical energy into electrical energy. So 1.5 joule electrical energy is produced. So I taught you this concept in the first class. What is the difference between EMF and PD? And in that class I taught you when EMF is 1.5 joule, it means 1.5 joule work is done to convert chemical energy into electrical energy. And if they ask 1.5 volt PD, then I would say 1.5 joule work is done to convert electrical energy into any other form of energy at load. It is across cell. So I should add in cell or in source. And now the last part of the question. The last part of the question. How many 1.5 cells are connected in series to form the battery? The total EMF of the battery is 12 volt. If one cell is 1.5 volt, then the question is how many cells will make the EMF of battery as 12 volt. So if I divide 12 by 1.5, Abata, what is the answer? If I divide 12 by 1.5, then the answer is 8 cells. It means if we connect 8 cells in series of 1.5 volt, then it will make 12 volt battery. So this question is also completed. And now I am starting question number 2. We are moving in reverse order. The reason is we are studying potential divider circuit, and in potential divider circuit two resistors are connected in series. It is resistor number 1, it is resistor number 2. Abata, give me the name of this resistor number 2. Yes, it is a variable resistor. You are right. It is a variable resistor. Okay. And the question is the PD across the 20 ohm resistor is measured with voltmeter. Draw the symbol for this voltmeter. It means if you have to measure the voltage या PD across 20 ohm resistor, then we will connect a voltmeter in parallel. So this drawing showing parallel circuit of voltmeter. So I have connected a voltmeter and this voltmeter is connected in parallel. And now the B part of the question, the PD across the 20 ohm resistor is varied from 0 to 6 volt. From 0 to 6 volt. Okay. And you know that if the PD across 20 ohm resistor is 0 volt, 0 volt, if the voltage is 0 across 20 ohm resistor, then what will be current beta? If the voltage is 0, then what will be current through 20 ohm resistor? Sir, current depends upon voltage. If the voltage is 0, then the current will be 0. So current through 20 ohm resistor will be 0 when voltage is 0. And when voltage is 6 volt, if this variable resistor having zero resistance, then the whole EMF of the battery will be applied across this 20 ohm resistor. So the PD across this 20 ohm resistor will be 20 ohm, and if the voltage is 20, sorry, if the voltage is 6 divided by 20, then the current is 0.3. The current is 0.3. Okay, but if the voltage is 6 divided by 20, then the current is 0.3. And they are asking to draw a graph. So I calculated these values and I am shifting these values downward. But when the voltage is 0, the current is 0. This is the first point on the graph paper. And when the voltage is 6, the current is 0.3, current is 0.3. This point will be here. And you know that according to Ohm's law, the graph will be a straight line. So this graph is a straight line for 20 ohm resistor. This graph is a straight line for 20 ohm resistor. When voltage is 0, then the current is 0. If the voltage across 20 ohm resistor reaches to 6 volt value, the current reading value will change to 0.3 ampere. So it will be the graph. And now the question is, a second resistor is connected into the circuit in parallel with 20 ohm resistor. Okay, another resistor connected in parallel. So remember, when resistors are connected in parallel, but Afra, can you tell me, when the resistors are connected in parallel, then what will be changed in the total resistance? Will it increase or decrease? Yes, in series circuit, total resistance increased. When you add any resistance, it will increase total resistance. But when you connect a parallel resistor, then the total resistance decrease. Then the total resistance decrease. The question is state. Statement is decrease. And they are asking how the combined resistance. So the answer is combined. When you connect, when another resistor is connected in parallel, combined resistance will decrease. In series it increase, but in parallel combined resistance will decrease. Okay, beta? And now the last part of the question, the PD across the two parallel resistor is changed. The PD across the two parallel resistor is changed and the current in the battery from each value of PD is measured. A second line could be drawn on figure 8.2 to indicate how the current measured by the ammeter depends on PD across the two resistors in parallel. State how the second line differs from the original line. Okay? Only you have to state, do not draw. But what about when the total resistance decreased? When the resistance decreased, then what will be change in the graph? हाँ बेटा बताएं. I am showing you when the total resistance will decrease. When the total resistance will decrease, then obviously the current reading for the same voltage will increase. When you apply 6 volt voltage, sir, when you connect a parallel resistance, then total resistance decrease. When resistance decrease, total resistance decrease, then the total current will increase. For same 6 volt voltage, for the same 6 volt voltage, the current reading will increase. The current reading, if increased, then obviously graph will be above this graph. And if the graph is above the green line, then what should I write? What should I write in the answer, beta? What about the change in the graph? Beta Afra? It is a straight line, beta. It is a still straight line. It is not a curve. You can observe on the screen, it is again a straight line. But what is the change? But when you are given a straight line, but please listen. When you are given a straight line and two straight lines are given, both are straight line, both are straight line. So there will be difference in their gradient. Its gradient is small and its gradient increased. It means there is a change in gradient. There will be change in gradient. The gradient of the line is changed. Okay, I am revising. I am repeating my sentence. Sir, when the total resistance, sir, when the total resistance decreased by parallel combination, total resistance decrease, so the total current will increase for the same voltage. If the current increased, then obviously the graph line is shifted upward. And if the graph line shifted upward, shifted means its gradient increased. So I should write its greater gradient. Because they are asking only state. Okay, so no need to describe, only state. So the answer is gradient greater gradient. And when the gradient increase, we can write the gradient is steeper. But Afra, is it clear or not? The green line, so the green line graph, when the resistance is small, sorry, when the resistance is single, it is 20 ohm. When the resistance is single 20 ohm resistor, it is a graph of single 20 ohm resistor. And this graph, when another resistor is connected in parallel, when resistor is connected in parallel, then total resistance decreased. When total resistance decreased, then the current through combined resistance will increase. So the gradient of graph is increased. So the gradient of graph is increased. So this question is also completed. And now the last question of the today's class, that it is question number one. However, it is question number one. And in this question number one, you can see the resistor graph is a straight line. The resistor graph is a straight line, and the graph of thermistor, sir, it is turning towards current axis, because we have been studying the graph of lamp. We have always studied the graph of lamp in which the graph turns away from the current. But if we study the graph of lamp, then it is turning towards current axis. Okay, and now start the question. The question is, calculate the resistance of thermistor when the PD is 7 volt. It means question about thermistor. PD is 7 volt. Sir, this is PD. This PD is 7 volt. And when the PD is 7 volt, then what is the current? My line is not straight. So this value is 4. This value is 4. So I think it is 4.2, 4.4, and it is 4.6. It is 4.6. Okay. If it is 4.6, then current is 4.6. They are asking resistance. Resistance is equals to V upon I. Sir, V is 7. It is 4.6, and if you divide, then the result is 1.5 ohm. Okay, beta? And now tick the boxes that indicate the effect of resistance and thermistor. And effect on the resistance of the resistor and of thermistor when PD across the lamp is increased. Okay, when PD is increased, beta, you can see the resistance of a fixed resistor always remains constant. If you increase voltage, but the resistance of resistor remains constant, the resistance of resistor will remain constant. But what about thermistor? What about thermistor? But when you are increasing voltage, it is becoming hot. When it becomes hot, temperature increase. When temperature increase, its resistance decrease. But resistance decrease. When you increase voltage, it increase temperature, it decrease resistance. So the answer is resistance will decrease. And now the question is, the thermistor and the resistor are connected in parallel to a 7 volt supply. Current from the supply. It means they are asking total current. They are asking total current for 7 volt supply. But what is the current? Sir, current, it is it is a chance, by chance. Sir, same point at 7 volt. Same point. And at this point current reading is 4.6 through resistor and 4.6 through thermistor. So the total current will be 4.6 plus 4.6, and it will be 9.2 ampere. It will be 9.2 ampere because at 7 volt the current is same. They are intersecting graph, current is same. And now the last part of the question, calculate energy from the supply. We have two formulas of energy. Number one, power into time. Number two, charge into voltage. Then what can we apply? We have, what can we apply? Power into time. If you suggest power into time, then I'm using, and power into time means voltage current into time. Okay, and what is the voltage of the power of 7? Sir, voltage is 7 volt. Okay, the voltage is 7 volt. When the voltage is 7 volt, then the current we calculated, the current is 9.2 ampere. When the voltage is 7 volt, then the total current through resistor, through thermistor, and through resistor, total current is 9.2. Time is 5 minutes. 5 minute means 5 into 60 seconds. And if you multiply all these numbers, the answer will be 19,000 joules. Okay. So in this video, I completed question number 1 to 5, but in reverse order: 5, 4, 3, 2, 1. So this video number 2, and then video number 1, you should follow in the reverse order. I will share my video after my class. Okay, beta?